where develop, implement, and execute a program using Yacc tool to recognize all string ending with B preceded by n number of A's using grammar A power of n followed by B. So what is the given question? You have to write a Yacc tool, that is Yacc program, in such to recognize. So if I give an input as this, that is n number of A's followed by B. See, for example, if I consider this input. See, if I give an input as a trip, one second. I hope this is visible. Yeah. See, if I enter my input as A followed by B or A followed by B, then it must say it is a valid input, because what the grammar they have asked us to follow A power of n followed by B. So you have to say, you have to find there can be n number of A's, but it has to be terminated with single B, right? So if I enter this as an input, it has to say it is a valid input. Okay. So for this question, you have to write the program. So as we discussed, first you have to start with Lex part, right? So Lex part, again, it consists of three sections, right? See, if you are going to write the Yacc part, I mean, if then you need not to write the C codes, that is user code. Okay, I'll tell you why later. Okay, so let's start with the definition section, where I will include the required header file. So as of now, you remember I have written a header file here. That is y.tab.h. I'll tell you why this is used when it comes to the Yacc part. Okay. So here, what are the things you need to follow? You need A and you need B to write the grammar, right? So next comes the rule section. So this is about definition section. Now it has to followed with rule section. In rule section, what are the things you have to consider? If you write input as, or if you write an input in a code as A, then it has to consider. Okay, so for that I'm writing a regular expression as A. If there is a in my input, then it has to written written action part as written A. Okay, so it says that whenever there is a in the input, it has to written capital A. Capital A is nothing but the token here. Okay, token that is generated for the input A, for the regular expression A. Okay, what is the next input given? B. Okay, if there is B in my input, then I have to check with the regular expression. It has to identify there is a B in my input, right? So for that, I have written a regular expression as B. Okay, whenever there is a B in the input, it has to recognize it as B and it has to return the token as capital B. Okay, this is the token name given for this input. Okay, so then if I write anything else, okay, then it has to written /n. It is nothing to do with code. You need not to write this. Okay, written /n, it is not required. If you write A and B, that is more than enough. Okay, and close this rules part. Okay, this is all about Lex part. So what are the things you are supposed to write? The regular expression here, whenever there is a match, what action it has to take? And it has to written A, and whenever there is B, then it has to written B. So A and B are the tokens here. So written where? Written to Yacc part. We'll see the Yacc part now. Okay. Yeah. Now, I said the first thing starts with definition section, right? Where I will write the required header file, that is stdio.h and stdlib.h. Okay. Next part is why what you have to specify what are the tokens you are referring from the lexical analyzer, right? So those tokens are A and B. A space B. So to say these are the tokens, you have to specify these with percentage followed by the keyword token. Then the Yacc will recognize these two are the token that is taken from the lexical part. Okay. So next, once you complete writing the uh, definition section, we'll move on to the rules section. This is rule section. What is this rules? What do we write in rule section? We write grammar, right? We write grammar, and rule section starts with percentage, percentage. So here I will write input, okay, colon followed by yes. So this yes says I'm writing a grammar. Okay, generally I have given a name for this, that is yes. If whenever there is yes, it has to print that is successful grammar. So what this S can take? What is the grammar that you are going to write? So that is given here. So that is yes can be either only A. See, input can only A, right? See here. So I'll take it. I'll take this. Anything. Okay. See here. My input can only be A, right? If A is there, and then it has to match with the grammar, right? It will check. Okay. But there is given question as A, any number of A's, but it should be followed by single B, right? So to satisfy that condition, I'm writing B here. Just remember here initially as A and B. So you just forget about this part. So I'll make it as yellow. As of now, you just forget this. Okay. If my input as AB, then it has to satisfy here, right? With the grammar. That's why I'll write the grammar as AB, right? Then what is the next question? N can take any value. It can be 0 or it can be 1 or it can be more than 1, right? What if I enter my input as A, B? Then it has to check with the grammar, right? Isn't it? So to satisfy that condition, I'm including A, S1, B. Okay. Now just think. Yeah. A, S1, B. So this grammar satisfied this, right? What is S1? So for example, S1 can be nothing or this symbol represents or A followed by S1. That means what? A can be followed by single A, okay, again S1. That means what? S1 is nothing but nothing or A. There can be single A, right, or double A or triple A or any number of A. To satisfy this condition, this grammar holds good, right? So that is how you write the grammar here. Okay, now with this B, right? So what if my input contains only B? What if my input contains only B? Right? Even this is also proper input, right? Because input n value. So n can be 0 or 1, right? So if you enter only B, then also it should give as proper grammar, right? So that's why I have written A followed by S1, B or B. So this B grammar satisfies if only my input is B. Okay. So this is how you write the grammar for the given question. Okay. So, okay. So this is how you write the grammar for this. And the last part is main C code or the user code where you will ask the user to enter a string. Okay, I will enter some string, then this function is called parse. When this function is called, it checks the grammar here. Okay, when it checks the grammar, it finds that A and B are required. Then it will check whether it is defined in the Yacc part. Yes, it is defined. Then this you have to refer it from the Lex program. That is A and B where you have written under rules section. So this is how it is referred. Okay. To say the Yacc that this these tokens are referred in the Yacc part, I've declared the header file as y.tab.h. Okay, this header file is included in the Lex part because to say that the tokens will be referred in the Yacc part which are generated in the Lex part. Okay, that's why I've included this header file. Okay, so this parts will look into the grammar. In the grammar, you know that the tokens are used, so it will go to the Lex part. It will check whether the tokens are generated here. Yes, it is generated, and it will be considered. Okay, if it holds good, it will say printf successful grammar. Okay, if the given input is not satisfying the grammar, then it will come to this part. It says, it calls the function error, wherein it says there is error. Okay, then it exists from the program. This is how you write the code. Okay, so is this example clear to everyone? Yes.
Yes, ma'am.
Okay, then this is how you execute the program. First, you will create the program. You will give a name to this program with extension Y. Okay, then you will compile the Lex part first using the command Lex. Okay, and then you will compile the Yacc program, that is Yacc space -d followed by name of the Yacc file and extension .1. Okay, then see, when you compile this Lex file, you will end up with C code, that is lex.yy.c. Okay, and then when you compile Yacc code, you will end up with C code, that is y.tab.c. Now you have to link these two and compile it. So that's why, because these two are C code, right? So that's why you have to compile these file with the help of CC, that is C compiler, and I'm going to link these two. That's why I've used -ll, that is link library for this. Okay, when you compile this, you will end up with the output file, that is /a. You will generate a output file. To execute that, you use this command, that is /a.out. Okay, so when you execute this, you will be asked to enter the string, where I enter it as a followed by b. So it has to check. So now if this is my input, then this input is given to where? It is given here. Okay. Lex takes the input, that is triple AB. It checks the regular expression. Is there a in the program, in the input? Yes, it is there, right? So then it will return A. Then it will check next A is there. So three A's are there. So three times A will be given to this. Okay. And then in the input B is present, it will check with this rules. Okay. Regular expression. Then it has to return this token. So B will be returned to Yacc. Okay. And then when parse is called, it will check the grammar. It will see the tokens. Okay. If it is properly generated, then it will say successful grammar. If I would have written the input as AAA, then it should say it is a invalid input. So that is how the Yacc program works. So That's all about the example for YY pass, and this is one example under your syllabus as well.